In Level 2, we will be evaluating composite functions from equations, tables, and graphs. This is review, and you might already know how to do this, so if you think you already know how to do the problems in number 3, do them yourself, and then you can jump ahead and see if you did them right. Or you're welcome to listen to my explanations right now. Okay, so for this first one in part A, j of k of -1 means we're plugging -1 into k first. So first we're going to evaluate k of -1, which means we plug -1 in for x. We get 3 times -1, all raised to the second power. Following order of operations, oh, that was -1 to the third. First I would do my exponent inside the parentheses. So -1 to the third is -1. So we get 3 times -1, which is then squared. 3 times -1 is -3, and -3 squared is +9. So k of -1 is +9. Now we plug +9 into j, and we evaluate j of 9. So the answer we got when we plugged -1 into k, now we take that answer right here, plug it into j. And that gives us the absolute value of, it's -x, so I get -9 plus 6. And that would be the absolute value of -3, which is +3. And that's my final answer. In part B, this is a different notation for the same thing we did in part A. So this little tiny open circle means the same thing. This is j of m of 8. So we're plugging 8 into m, and then whatever answer we get, we plug that answer into j. So first we're evaluating m of 8, which would be 8 to the 2/3. Now remember, with rational exponents, your denominator is a radical. So this is a cube root of 8, and then the numerator is an exponent, so 8 squared. 8 to the second power is 64, so we get the cube root of 64, which is 4. Then we take that answer we got and we plug 4 into j. So we get j of 4 is the absolute value, again -x would make that a -4 plus 6, which is the absolute value of +2, which is +2. And that's our answer. Now in this last example, this one's a little bit different. When you have an operation, addition, subtraction, multiplication, or division inside this first set of parentheses, what we're actually going to do is take this number and plug it into both functions. So we're evaluating both k and n for when x equals -2, and then we take the two answers we get and subtract them at the end. So first we're going to find k of -2, and plugging -2 into k, we get 3 times -2 to the third, which is then squared. -2 to the third is -8, so we get 3 times -8 inside parentheses, which is -24 squared, which is 576. Now, we're also going to evaluate the function n when x equals -2. So we don't plug the answer we got in, we go back to the -2 and plug that into n also. So n of -2 is 2 times the square root of 7 minus -2, which gives us 2 times the square root of 9, 2 times 3, which is 6. Now we take our two answers that we got and we subtract them. K came first, so 576 goes first, and then -6, and we get 570 for the answer. In the next two examples, we'll be looking at composite functions in tables and graphs. In this first example, we're looking at a table, and we have to evaluate f of negative 1. We start on the inside, and we first find f of negative 1. Negative 1 is the x value, so we go in the x column and find negative 1. And then we go over to the corresponding y value in the f column, and we get 2. Now 2 becomes our new x that gets plugged into the outer function, which is also f. So we find f of 2. We go back to our x column, find 2, go to the corresponding y value in the f column, and we get 1, which is our answer. In the next example, we will be finding f of g of 0. So we go to, first we're going to find g of 0, and we go to 0 in the x column. Then we go over to the corresponding y value in the g column, which is negative 1. Now negative 1 becomes our new x value, and we find f of negative 1. So we go to negative 1 in the x column, and now we go to the corresponding y value in the f column, which is 2. Now from a graph, it's pretty similar, same idea. This means f of g of 3. We start on the inside and find g of 3 first. 3 is the x, so we go along the x-axis to 3, and then, which is right here, and then we go to find the corresponding y value for the function g. Now g is the dotted line, so that would be this point right here, and the y value of that point is 1. Next, x will become our new x value will become 1, and we find f of 1. So we go to 1 on the x-axis, and which is right here, and we find the corresponding y value for the f function, which is the solid line. That would be this point right here, and the y value is negative 1. And the last one has 3 parts to it. First we will find f of negative 3. So we go along the x-axis to negative 3, and we go to the function f, which is right here, and the y value is 1. Now we find g of 1. 1 becomes the new x value. We go along the x-axis to 1, which is right here, and the value of the function g at that point, since the dotted line is crossing the x-axis, the y value is 0. So g of 1 is 0, and now we have to find f of 0. And f of 0 would be 2, which is our final answer.